Hello. Hello. Hello.
Yeah. Hear me?
Yeah, I can hear you.
Okay, so we are connected.
Yeah.
Uh, let's wait for a couple of minutes.
Okay.
We have 3 people. So we'll start in a couple of minutes. Is that all right?
Yes.
Yeah. Let's start. Okay. So Rohan says he has some doubt. Okay.
Yeah.
Then discuss the points that I have put out. Okay.
Diganta, can you hear me?
Yeah.
Yeah. So my doubt was with the merging of nodes that we're doing. When we were studying the node merging abstraction, there were some rules about the uh, weights of the incoming edges and the outgoing edges, which ensured that was an over approximation of the original network.
Mhm.
Law method, or even the one that I suggested, where I haven't still figured out the weights yet. How, like, do we have some kind of a proof or some kind of an intuition that this is indeed an over approximation of the neural network?
Yeah, yeah, we definitely do, right? So, see, there is two, again, there is broadly step two and step three, right? Step two is the one which decides what to merge. Now, independent of that decision, in step three, what we are doing is we are deriving some bounds which are guaranteed to be over approximate, right? Because we are proving that for that group, the bounds holds using Madabu, right? So if you remember in step three, what we were doing is that
Right.
we were looking at the bounds, and we were proving that those particular bounds indeed hold using Madabu, right?
Right.
So when we're doing that, we're making sure that the bounds that we're getting is sound, and therefore, if we replace the group of neurons with an abstract neuron that follows those bounds, we will have something that is guaranteed to be an over approximation, right?
Okay. But once the node has been merged, we are actually deleting all the outgoing edges from that node to any of the.
Yeah. So what we're doing there is whenever we're deleting an edge, like I was saying,
Sir has some.
um, we are replacing
Can you
the.
wait for a bit? It's like sir is saying something.
Oh, okay, so yeah. Well,
Yeah, and I'll sit here. Okay. Yeah, I just wanted to get the others involved on the first question. Okay. So let me understand the first question. So you're saying, what is the guarantee that when you replace it with the, why is what you're doing will create an over approximation? Okay. So is that doubt clear? Because assuming the bound, in the way I understood, I wasn't fully paying attention to Diganta's explanation. The way I understand, correct me if I'm wrong, Diganta, is assuming that whatever the bounds that you derive as described by Diganta in his document, if they are sound bounds, okay, then all you're doing is you're setting that value to the upper bound, correct? And
Yeah.
therefore, so since the actual value for any particular input value can be anywhere in that range, if it's an increasing node, you set it to the top, then you assume that if anything, it gives something greater than the existing, actual value. So that is the reasoning for the that it is sound. Now, the bound, the derived bound itself, as per whether the way the method that Diganta proposed is sound or not, is something that needs to be checked, or you may not be able to check it formally in the sense of automatically, but you'll have to argue. Okay, you'll have to have a proof that that it is sound. Okay, so that question was clear, no? Okay.
No, but why are you saying that the bound needs to be checked? Because we are checking the bound using Madabu when we are deriving it, right?
No, but you yourself had that one note there, you remember? Where you said, check if these bounds, the way they are, so you propose that you derive them are indeed sound. Okay, so I'm trying to understand that note.
No. That note was only regarding the closed form of the integral for the LP step.
I see. So the bound derivation is not dependent on that closed form?
No, so even if the bound derivation is not, in the sense that even if the closed form is wrong, you will get probably something that is not a tight enough bound, but you will still get a sound bound.
So your soundness of the bound is guaranteed. That what you derive is indeed valid bound is guaranteed by phase 2, correct?
Yes. And then eventually we are making sure that it sound using Madabu. So it is guaranteed by phase 2. Yes.
That's correct. Okay, then I have no issues. Okay, I'll take that back. So, but what this method of phase 2 through Madabu, what is not guaranteed is that whatever is the tightest bound is not guaranteed. Okay, so it's tight up to a certain this thing. Okay, it depends on the step that you use in your binary search. Okay. Yeah. Okay. So yeah, you want to add anything else?
No, thanks.
Okay. Any other questions?
Yeah, so he had a second part of his question, the second question where, yeah, he was talking about the outgoing edges from the merge group. So see, for the other outgoing edges, what we are doing.
No. What was the question? What was the question about the outgoing edges from the merge group?
So
give the mic to him. What was the question?
Yeah. So when we merge, so we delete. So when we merge the nodes, so we are deleting the outgoing edges from the merge node. And say in your example in the document itself, there were some green nodes which were found to be linearly related to the output, and some of the outgoing edges from the nodes inside the merge group are going to those green nodes, right?
yeah.
So if those nodes, is it guaranteed that those remaining nodes, which are the green nodes, will still remain functioning as a linearly related nodes to the output if some of the incoming edges are deleted?
Right. So if you do delete those edges, then yeah, maybe the linear relation will still not hold, but nonetheless, it will still be sound in the sense that, okay, let me share and
yeah,
explain
I have
this.
made you a co-host. I think
Yeah.
that you share when you as you described.
Yeah. So yeah, let me just open up that document. No, no. Yeah. So here, when we are looking at, say, so you're talking about these red edges that are being deleted, right?
Yeah.
Yeah. So here, okay, I think my Wacom tablet for whatever reason is not working. It seems.
I mean, your question was, what about
Yeah.
the red edges?
So what we're doing with the red edges
Diganta,
is,
wait.
yeah, sure.
I'll just repeat my question first, sir.
Yeah.
Yeah. So my question was that if we delete, okay. So my question was that if we delete these red edges to the green nodes, which we've already found to be linearly related with the output, will these nodes still be linearly related with the output, or they will lose their linear relation because of some of the data coming in from the red edges have been deleted? Yeah, that's it.
Yeah. So yeah, that might definitely happen in the sense that see this node, the fact that is linearly related with this output, it is dependent on the fact that or at least to the extent that we know that is linearly related to the output, is just by looking at some of the simulation data, right? So it's just by looking at the values seen at the output of this node and the values seen at the output of this node and so on, right? But of course, what might definitely happen is that the values seen at the output of this node, this depends on the values coming in via these edges. And if you were to delete those edges, you would have seen different values here. So you might lose linear relation here. That is correct. However, what will not happen is deleting these edges is still going to be a sound over approximation, because when we delete them, we are not just deleting them, we are replacing them with the the largest or smallest value that can come via this edge, depending upon whether this node is inc or dec. So for example, if this node is dec, then when we delete this node, we know that, okay, we need to look at the smallest value coming in via this edge. So we look at the smallest value that can come in via this edge and add it to the bias of this network out of this node, right? On the other hand, if this is inc, we look at the largest value coming in through these nodes and add them to the bias of this. Okay. So that way, it is still going to be a sound over approximation. But what might not happen is that once you delete them, the linear relations may not hold. Yes, and that is something that we're not taking into account for when we're selecting this punch group. So yeah, that is a fair criticism.
Yeah. Yeah, but I have one question here.
Yeah.
That you said that you will take the maximum of what? Maximum of all the weights or what?
No. So remember that for each one of these nodes, we have some via interval propagation, some linear, some constant lower bound and upper bound, right?
In that bound you will replace with that maximum or min of the bound.
Okay. Right, exactly. So specifically, if we have a green node over here, let's say, and this is seeing some edge from or it might not be a green node, but it just needs to be some node, and it's seeing some edge from a blue node that is going to be deleted, right? And we know that this blue node's value lies in this particular bound. So depending upon whether or not, so if this node is in, then when we delete this edge, for it to be sound, we want to replace the values coming through the edge with the largest possible value that can come through the edge, right? So what will that be? So if this edge was positive, then that will be the upper bound of the of the values that this node can take, right? Similarly, if this node is negative, it will be the lower bound, right? So we'll select the lower bound or the upper bound and multiply it with the weight and correspondingly get the largest value that can come through this edge and replace this edge with that value basically. And by replacing, I mean adding that to the bias of this node. Similarly, if this one would have been deck, we would have taken the smallest possible value.
Yeah,
So
but
this is
here
what
also
we do.
there's another question. So there is this constant bounds,
Hmm.
as well as, you also express the bounds in terms of as linear expressions of the inputs, correct?
Correct.
Which one will you use?
No, we are using the constant bounds here because see, at this point, we've still not derived the linear expressions. We have just,
So there is that step after this. Okay.
yeah.
Okay, good. Then I got it. Yeah.
Yeah. So does that answer your question?
Yeah.
So
Sohan has some questions. I'll pass the mic to him.
In the step 2, so we are when you are defining the score function.
yeah. Yes.
Yeah. So I have a question. Like, how are like first of all, like yesterday I asked the same kind of question. Like, we are kind of finding different subsets of inputs, and then like trying to find those scores based on that, and like running the linear solver on those kind of specific set of subset of input, and then trying to find out which is the sort of the best one. So then we are. My question is, then we are. This, have written this. There are two corner cases. Like, so how do we like, get this threshold? I mean,
Right. So you're asking about how do you actually find the threshold value?
Yeah.
This TC?
Yeah.
See, there is no easy answer to this. So the idea is that you will have to sort of do some trial and error. This threshold value, if you think about it, there's two threshold values here in the entire algorithm, right? There is this one threshold TC, and then there is also TS later on, which decides if a score is good enough to perform a merge, right? Both of these threshold values, what they control is what the size of our merge groups will be. So if we use a very small threshold value, what might end up happening is that you'll get no merge groups, right? So in that case, when you do the entire merging, your abstract merge network is just an original network only, right? So that is one end of the spectrum. And at that end, of course, you might be able to prove the property, but you'll basically spend a lot of time. You're not getting any time benefits out of doing the abstraction. On the other end of the spectrum, if you use a very large value of threshold, what you might get is you might get really large merge groups, which lose a lot of information. So in some sense, the over approximation will become too coarse, right? So at that end, you'll go, the queries and the Marabou calls will go through fast, but you might not be able to prove the property. You'll get a spurious counterexamples, right? So the good value of TC and TS lies somewhere between these two ends of the spectrum. Now, where exactly it will lie, that is very hard to tell a priori. And right now, I don't have any, do think about this, but I don't have any way of actually telling you where it will lie, right? What you'll have to do is you'll have to do some trial and error. So you maybe start with some value. If the proof goes through, well and good. Otherwise, if you're getting spurious counterexamples, maybe try half that value, right? If it takes too long, maybe now try something between the last two things you tried and so on, right?
Yeah, but this is a very good question.
This is a very good question.
Yeah, because this can be used. I mean, one thing is that you don't, I mean, you have to do trial and error. That is, but then it is like, as an analogy, it's the same thing. You know, how many, you remember that in the original node merge abstraction, there was this question of, merging to saturation. Okay. After that, I mean, how do you know? So the same question, when do you stop merging? Okay, you can merge it up to saturation. And then if, you're not able to prove you're not able to prove the property, it's not a real counterexample, then you have to figure out a way of dividing the merge, right? So here that the value of TC and TS that you choose can be considered as a way of controlling your the coarseness of your partition, and you could refine it. You could use that as a tool for refining. If something does not, it's too coarse, the choice that you're made for the TS and TC's too coarse. Now, the question is, how do you start? Okay, when do you start? Okay, that's just, we don't know. I mean, you could use, I mean, if there are some good ideas, then we can do, or it has to be trial and error. Yeah.
Yeah, so this is Rohan. I have a small idea about this. Like, what we could do is define a small neural network, maybe of 20 or maybe 10, 20 nodes, and then simulate a noisy straight line 20 times, maybe, maybe in some n-dimensional space, and then see what the network does and what kind of thresholds we get when we apply least squares method calls on that whole network. So if we are generating from a slightly noisy straight line approximation, we are bound to get a good threshold when we are applying a least square call on that. And by that, like we can use values which are closer to that in our own Zoom network to find the to get TS and TC. Like we just add some kind of a random noise so that it just doesn't fit a exact straight line, otherwise the threshold will just be zero. So we add, so if it's y equal to m1 x1 plus m2 x2, then we add this m plus c, then we add an epsilon which is say normal 0, so that the points won't lie exactly on the line. So what we do,
So
simulation, yeah, I'll just answer, sir. He is asking that what are we actually doing here? So what we do is we simulate from x1 and x2, we simulate y with the no, in general, just we get the data y equal to m1 x1 plus m2 x2 plus c plus some noise, right? We generate y from x1 x2, say 1,000 samples, and then using those samples we fit the neural network that we have made, just some basic fully connected neural network of and y is just, so x will be the input to the neural network and y will be the output of the network. The y is just trying to guess. Right. So we could make the neural network in such a way that it represents a kind of a merged group that we're trying to merge. Yeah. So a smaller, yeah. So that's why I said a smaller network of maybe 10 neurons that we can merge, and that y will simulate the output neuron of that merged node, so that we will understand what kind of beta values or coefficients we get for each neuron when the square calls return, and also the absolute threshold value or the actual error value of the these call error, so that we get some kind of intuition for what TS and TC should look like, and even the threshold for the betas should look like the coefficient of the nodes that we can apply to the actual neural network.
So I have a question. This seems like a really good idea, but like, how would you decide how much noise to add? So when you're adding the noise, you'd probably take some Gaussian distribution and add that as
Maybe we can run some simulations on the like a noise of say 0, 1, then maybe we increase the variance and add that noise. And that way we can even be able to plot what TS and TC values look like. And that way we'll be able to maybe get a balanced value out of it.
I see, I see. So the idea is that then you won't have to, so now you don't have to like play with two values, but only one value, which is the variance of this noise, and you have a table of TS and TC values
Right.
according to. Yeah, that's actually that I think that's a good idea. I mean, you can do that, I think. So okay, so you have a network for which is learned this noise, and then when you're going to like learn this noisy line, then when you're going to extract the TS and TC, like how are you choosing what the quote unquote correct TS and TC should be for a given level of noise?
That's also a question I had. How do you?
Right. So if say the neural network is of 10 neurons, excluding the input neurons, say, what we'll get actually is the actual coefficient. So what we have done basically is ask the neural network to plot a linear regression. Like
Right.
linear regression. It is already a straight line in some dimension in space. So it has learned that. So now what if we use the simulated values on those nodes and do the least square query, then we will get the beta values. And for this case, we already know that all of these are significant because every node will contribute somewhat to the linear regression because that is what we are learning. So we already know that all the nodes are contributing to it. So what we can do is look at the least coefficient in all of the network, and that can be our TC.
Okay, so your network structure firstly is just a single layer, which is learning.
Maybe single or double layered, but very small network and completely fully connected with the ReLU activation, nothing else. No signal.
Right.
And in the end, we'll get some value. And for this neural network, since we're asking it to learn a straight line, we will know that all nodes should be contributing.
All the input nodes.
All the input nodes should be contributing, and since it's a ReLU network, and say we simulate only positive value, we will know that all the hidden layer neurons will also contribute because
Why I didn't get that. So can you repeat why all the hidden layer neurons should also contribute?
Sorry, I didn't understand. Sorry.
So why are you saying all the hidden layer nodes should also contribute?
Because in the end, every hidden layer neuron is also getting the input from the input neuron itself. Right? It's just a perceptron. And if the input and the output of the first layer say are all positive, ReLU will just give back X, nothing else. So that is being fed forward.
Yeah, but it might not be positive, right? So it might be. So I mean, for example, it might be the case that the hidden layer is actually calculating something non-linear. Like that is something that is strictly non-linear. And then the final output layer is calculating the noisy linear function that you're looking at, right?
Okay.
I mean, like you can come up manually with networks which sort of look like this, where the intermediate layer is strictly non-linear, but the composition of these two layers, like the second layer output does behave linearly. So I think, yeah, like it's definitely true that the input neurons have to contribute because again, the network is learning something linear in the input neurons, and those have to be there. So we can use that as a, that to guide the threshold value, right? But at that point, we don't even need to train the network, right? Because the value at the input layer and the value at the output layer, it's basically the same as the training data, right? If we have trained the network to some good enough point, it'll be basically training data plus some noise, right?
Right.
So essentially, then we can get away with not even training the network, right? We can just take a line and
on the input neurons itself.
Yeah,
we can do away with the network and get the least square call only on the output and the input layer.
Yeah. We can just take a line. We can just take some lines. We can just add some noise, do the least square, right?
Yeah.
And then see what the minimum score and what the coefficients look like, right?
Yeah.
Yeah, and then we can do this for multiple lines. We can maybe add some zero coefficients to help distinguish it, right? So yeah, I think that is a good idea. So what we can do is, we can take, say, 10 lines where we know that some of the coefficients should be zero, right?
Hmm. Hmm.
And then add varying amounts of noise. And then we know that, okay, TC should be something that makes the coefficient that should be zero, zero, but it keeps the other coefficients as non-zero. And TS should be something that is, that like says that this is actually linearly connected, right?
Right. The more noise we add, the TS will increase, and at certain point, we just decide that this is too much noise, and we have to
Yes, yes. And then basically then we'll have only one slider to play with, which is the this amount of noise. And for any given amount of noise, we'll have this table which will give us choice of TC and TS. Right?
Right.
Right. Yeah.
Yeah, so we keep. Yeah, so sir has a question that we have to choose the noise as well. So what we could do is just keep increasing noise in each of the, say we are simulating 5 lines. So we keep increasing noise in all of them, and we look at the TS scores of each. And at a certain point, we decide ourselves that this is just too much noise for it to be represented as a line at all. And we look at the TS scores of that noise level in each of the lines.
So
Decide to keep the TS levels below that.
yes, so that is one way. But I think the more important, like at least to me, I think one of the reasons why this seems like a really good idea is the not just the fact that, like, it doesn't really solve the problem. Is that you still have to choose a particular level of noise. But now what we have done is, instead of having two threshold values, see, previously we had two threshold values, TC and TS, to play with, right?
Right.
But now what we'll have is, we'll have one amount of noise, one variance, and for each value of this variance, we'll get one TC and one TS.
Hmm.
So that is what seems like a really, because now, having to tweak one variable versus two variables is a big improvement, right?
Yeah, just
Especially when we don't know we don't have much intuition about what the relation between the variables and so on are.
yeah, just one second, sir wants to say something.
Level point that I want to make. See, whenever you do, okay, it's quite good. You can try and be very clever and try to get as precise as. But one thing overall is that the more complex and smart and clever that you get to either compute the abstraction, how precise you want to make it, or during refinement, how you cut. By being clever, I mean, the more complex it becomes in terms of the computation effort that you expend, it contributes towards the overhead, okay? So if the amount of effort that you spend in making the initial abstraction itself to be very precise, okay? When you don't know how precise you ought to be, etc. And while refining, trying to, the criteria that you use to refine, if it involves a lot of computational resource, eventually that overhead might come to bite you, okay? Because you will have to put that effort right in the beginning. So some of these things have to be, you want it to be very inexpensive when you do. So you have to strike a balance there. No, I don't know how much effort it is to do this fitting and then do them, because that you might have to do every time, okay? When you do the refinement, if you don't, I mean, maybe for the initial TS and TC, that might be a good thing to do. But then after that, if you want to keep doing that every time to find out the new TS and TC, then it may not be depending upon what the computational cost is. Okay, so that's just a engineering. When you design heuristics, that is very important. Okay, that you will have to keep that cost. What you criteria to decide. As is one of the concern that I have for the scheme that the merging method that Diganta is suggesting, while it has a lot of attractive things, okay, and it seems certainly more precise, than the regular thing. That one, the cost is very, very minimal. There's absolutely no cost there. Okay.
Yes, yes, this is much costly in
This
this.
is much more expensive. The hope is that you will get something which is better, but that is the proof is in the pudding. Okay, so you will have to see what happens through the experiment and so on. But that is something that you keep in mind. I mean, I think it is good to explore certain things, you know, with these things in mind. Yeah. Okay, Diganta, you sent recently an email. I don't know if it, yeah, where you had added some more details to some of the steps. Do you want to go through that?
No, 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 no. I had forgotten to upload this version of the document where I made some notes. So I just uploaded that at the beginning of the class.
Oh, these things that you wrote as markings, is it?
Yes, yes, yes. The notes on the margins and such.
That's all.
Yeah.
So then if there are, I mean, are there any other technical questions about specifics about the algorithms and so on? I mean, you could come back to us later also. Yeah. Okay. So now, you know, I want to decide on a few things about the logistics thing. See, primarily, I'll be gone from 23rd to 29th. Okay, it's pretty much because the Diganta will be there. Okay, so I'm kind of. Yeah, I know that. But our deadline, at least the current deadline, is December 30th, right? Oh, I'm sorry, November 30th. You know, so if indeed you'll be busy, you'll not be working on, then our deadline is pretty much 28. I mean, when is the start of exam week? 23rd. Yeah, but you say hours. I don't know if everybody's. Yeah, they'll have some exam. So, okay, so given that you won't be able to do, and then you will have maybe a week now, pretty much a week, right? I mean, not even a week, okay? And then you have maybe a few days after your last exam. So, you know, maybe 10 days, assuming that you will not be able to spend any time during that week, probably, and even otherwise, it will probably be 50% of the you'll be spending. So that's what is giving me a little bit of concern, okay? Now, you know, whenever you do this kind of a project, we always want to do, every time I also do, so I'm a little bit ambitious, okay? And we start, you know, I want something, you know, to come out of it. I mean, and usually something has come out of it, which has led to something a little bit, you know, something that gives us group some satisfaction, a little bit of fame, and whatever, okay, and reward in whatever. So given that, I want to be realistic, okay, about what can be done, and that's why I wanted you to give it some serious thought. And it is from that point of view that I put that thing. If you could bring up the mail, I mean, in the notes that I sent, Diganta.
Yes, yes. Yeah.
Yeah, or I can bring it up and you can stop sharing, which one of the two.
Either works for me.
No, you share it, okay? Because I'll be
Yeah.
going around. Okay.
Yeah, yeah. Is this Zoom okay?
Yeah, yes, start from where I have, yes, this is good. Okay, so the overall thing is, I know, I mean, I've split it up into three tasks, okay? Just for some working thing, and then you will have to implement all those things. Now, if you want to, what is the way to reduce the burden on, you know, one way is we will provide some modules. Okay. Now, I don't have a buy-in from Diganta and Harsh for this, okay? Because we, on their behalf, I say we will provide. I have to get their buy-in also. So some modules, if we provide, okay, like for example, this, I mean, I was just thinking, what is it that something that has to be self-contained and we can provide? Okay, maybe that thing where you will have to, so, you know, traverse through the network to identify all the paths, to identify the nodes, etc. That is one of the tasks. Okay. Huh? No. It's after you found all the inputs to the merge node, you have to identify the internal nodes, the blue things, for which you'll have to do some things. So that
So
is
this algorithm you're talking about.
yeah. Now that is one thing maybe that can be and then I also see that this certain amount of effort is required to smoothen out. I mean, the interface, the I call as what is it that I yeah, that's one. And what else? I mean, see, no matter what, okay, maybe we can identify a couple of tasks like that, which will, what I was saying was maybe that there's a least square solver module. What is the interface for that? Okay, you know, if that.
I'll show that. I'll actually show that. Let me just show that. I think so. Yeah. There is this one, and then there is a version in SciPy which usually will have more knobs. Yeah. So is the Zoom okay? This is the interface.
Yeah, this is all fairly clear. I think there's nothing.
Yeah, there's nothing here. So you just have to pass in a. So
Actually, this is not what I'm worried about. I think what I'm most worried about is in the second step 3, okay, of going under the hood of you're pretty much having them implement, they'll have to implement this algorithm 5, 4 and 5, I guess. Okay.
Yeah, 4 and 5, yeah. 4, 5 and 6. 5 is not okay. I mean, maybe it's just because I've implemented versions of 5 several times over, but I think 5 is something that they already a lot of it they already probably have done as when they were trying things with Madabu, because this is just encoding a network in Madabu, right? So 5, I think a lot of the code should already be there with many people. Am I wrong?
No, but I don't know if they've even done that yet. I don't think they even knew that that was a sign. You were not very clear about it. Have you done this? What do you mean this is done already? They should have done. I don't.
No, as in, have you guys tried? So you have installed Madabu, that's fine. But have you guys tried encoding a network into Madabu and? I mean, if not, then that's also okay.
Coding preconditions and so on, is it?
Yeah, it's just encoding a network, encoding preconditions, and the post condition is just the bound.
Yeah, but why? Okay, so that is. But even that you'll have to write a program for that because the entire system had to be automatic, correct? So.
Yeah, I mean, yes, we will have to write a.
Yeah,
you'll have to set up the Madabu query essentially. But if you guys haven't, then this is one piece that I think I can provide very easily.
So see, this is where I wanted everybody. So anyway, we have a rep from each group. So I'll take it. Okay, Soham, you are representing the other group here, right? You're the sole representative from the other group. So let's suppose that I insist, okay, you guys have to implement, each team has to have do one implementation. Let's suppose that I insist, okay? Then if you were to do that, I don't know if you've had an opportunity to discuss with your teammates. Oh, they're no, so they're doing. That's fine. I'm not blaming them. So I think if I insist that, then what I'm saying is you tell us, okay, that this will be hard for you to finish in 10 days. That's almost, maybe even if you're assuming that you have certain, given the, I'm saying 10 days worth of effort effectively you have, okay, for doing this. And you have 3 people, how will you apportion the tasks, for you to do it? I mean, and then, if you need help, then we'll have to provide some module for it. If we have to provide some help to you, which means that we will give you some code, okay, but that has to work with your implementation. Therefore, anytime you say we have to share, and then you'll have to, you can use that module that we provide in a plug and play mode. The data structure will have to, the interface will have to work, and the data structure will have to be in sync, correct?
Yeah, so we'll have to decide on the data structures and interface.
Yeah, which I thought a little bit, and it's not very difficult. I mean, you can have one, if you use kind of an object-oriented way of doing it, one global thing with, I mean, I'm thinking of C++ way, okay, where you have a class and then you have certain things so that it is extensible. When you think, oh, I need to add one more piece of field, one additional field, then you can keep on extending it, okay? And then you can define new methods as you go along, and which we could do jointly. Then, but for that, say, okay, these are the things that maybe we can provide, okay? And then, that's the kind of decision that I want to make. In the extreme case, I didn't even want to mention this, okay? But I'm mentioning it anyway, because once I let that, rabbit out of the hat, then that will be a crutch that you will end up using, which is, I'm saying, I mean, these are the tasks. This is what I definitely want to know who's doing what, okay? So that I'll have some idea. Anyway, you can interact, collaborate, however much you want, but eventually the different components have to be put in together, and it has to work. So someone has to take that responsibility. Okay? So if someone slouches off, then your entire effort will be gone. That's why it is important that you have the discussion. So the other, when I say, I mean, what is the rabbit that I think? Okay, we could spread all the tasks across the 6 people. I don't want to do that. And if that is the only way we think that we could do, then then the coordination becomes even more important. Okay? So, and everything that thing, what is the plan? What is the task? Who will do what? What is the representation, etc. Regardless of whether you distribute all the tasks among the 6 people and then you integrate, which I don't want to do. Okay, whatever is, these 2 modules will provide. Okay, you do the rest. So then it will be, responsibility will be clear. If you have 6 people, I work with companies and so on, so it's very difficult to coordinate. Okay, everyone has his own thing, and nothing will get done. Okay, and the coordination burden will fall upon one of us sitting there at college meetings. That we can't even do that. Therefore, the best thing is, assuming that Diganta and Harsh are willing to help. I don't know, Harsh also has exams and so on, so I'm not sure how much he does. And, I don't do much coding right now. And, that's why, I'm calling.
So I'm not sure. I've not discussed this with Harsh, of course.
Hmm.
But from my end, I think like there are some modules which I'm confident I can do in a very short amount of time. One is this one, the encode Madabu module, of course, because this is some code that I've already written in several ways in several places, so I can like get it done fairly quickly.
Which one? Algorithm 5?
Algorithm 5, yes. This is there. Then the
This one of where they invoke the getting the actual bound, where they invoke Marabu,
yes.
that to be done by them. Okay.
No, so this is okay, sure. Yeah, makes sense. Yeah.
Diganta.
Yeah. So then what? Okay, then let me look at the other algorithms.
Hello.
Yeah, go on.
Yeah. So we have pretty much done that, like the algorithm 5.
Okay,
and
sure,
put it
sure,
into
sure.
Marabu, right? So we
Right.
have written the queries for verification of the properties in the Akash Zoo. So taken one neural network and some properties. So like the input, the queries we have written, the output we are not really getting what we wanted, but like we are comfortable with writing queries in Marabu. So I think this algorithm will be okay to do. by
Sure,
ourselves.
sure, sure. So then what do you guys suggest that like if you want one module, what would it be?
Put in there's some effort for in the way that I've described. There's implementation effort, there's experiments. Okay. So experiments is also there. So you'll have to remember that. And then, there I want to, we can get the properties and so on. So, but you still have to run it on that and run it on the original system and generate some kind of a table is what I'm hoping. So anyway, going back to Diganta's question, if there's one module that you would like to, be handed over to you, what would that be? I mean, I still think it's algorithm 3, isn't it?
Algorithm 3.
Which
Yeah,
is,
sure, sure.
which is kind of, I would say that's the most boring part of it, in the sense it's not
Yeah.
related anything to do with the actual crux of it. Huh? It's just a graph problem, isn't it?
Yeah. So sure. I can.
Yeah, but then that will also mean that you will have to agree on some data structure for representing the network, correct?
Yes. So what I suggest for that, since this will no longer be a purely feed forward in the sense that there might be connections that are going across the layer and so on, I suggest that we treat the neural network as an actual network. We can use network X or some other graph library. So we treat it as an actual graph. That will make certain things more complicated because things like evaluating and all, you won't be able to make use of NumPy and linear algebra and so on. But it will be some.
Diganta,
yeah.
I mean, there are lots of, if you choose what you're suggesting, if I understand you correctly, is choose some standard package, some graph thing. Yeah. See, but the problem is there are very scheme specific thing that you will have to add. Okay, for example, even if you have these graphs and there are nodes, now how will you, I don't know, ideally I would add all these values, these vectors of values, because they're associated with each nodes, I would have them as fields inside the thing. Now, otherwise you'll have to have a separate data structure for that. So if you use a standard package, you can't go inside that and then muck around with their data structure, right?
Yeah. So actually, I mean, I guess this is some high level view that I have. So when I would basically usually have it something like this. I would have some graph, like an actual package which has some graph data structure, right? And then this will give me some indices of neurons and all of that, right? So and then for the vectors, for example, associated when we get the simulation, or the index classification, or the things like the lower and upper bounds, I'll have all of them as dicts or maps, right? So this will have some set of edges, and each edge, sorry, set of vertices, let's say, and each vertices will be something like an index, right? So this will be basically just an int, and then what we can have is a map, something like a hash map, which will take this int to say,
Yes, you could do that. I think so. That's what you will have to have. You will have to have a separate data structure that maps it, and then you will have to index into that. Correct.
yeah, that is what I had in mind, but simply because then we don't have to worry about implementing. I mean, I guess it's not much to implement a graph thing, but yeah. So, what do you guys think? Would you prefer something like a graph and then, indexing into various dicts for the various stuff associated with each node or each edge? Or would you rather prefer a graph where you have these as fields of the classes?
Right. So Diganta, what my thinking was that
Hmm.
after the first two algorithms where we are actually finding the nodes to merge and everything else.
Right.
In the third algorithm, if you just decide on a data structure yourself
Hmm.
and just implement the module and just let us know how to use the merged network going forward, that would still be okay, because like we don't have to think about what you have done inside the code or the module or class, whatever you have defined, and as long as we just get the functions to use it, or some instructions on how to use it without the basic functions or how to use standard functions, that should be good enough for us, because that's
So-
all we.
Yeah, that's fair. But like here, when you're saying standard functions, what kind of functions are you talking about?
So whichever functions you already know what we have to do in the next three algorithms. So if you can just give us some kind of a README file on how to do that for the next algorithm, like whatever functions we need to invoke,
Hmm.
this is how you invoke them. Then we don't actually have to understand what kind of data structure you have to use. Yeah, sir has to say something. Just 1 second.
That, for example, the pre-processing step, if you want to implement it yourself, that will take some network, will split all the nodes, that will have its own graph structure, right? If you use a
Yeah.
different data structure for that, and then Diganta is using a different data structure to walk through the thing, and even having a small same function will not help. Okay. So, I mean, you will have to agree right now that all our node, I mean, the graph data structure that will be used to represent whatever network, the network will be uniform across these two modules, correct? Yeah, because you will take that data structure and then you'll be splitting. Now, then you will have to do the thing. So then, yeah, so if you use the same graph data structure, we'll agree that this is the graph data structure with all these functions and methods, etc., to manipulate them. You use the same thing and produce it, and then, then you could plug his module.
Hmm.
Yeah, anytime you have to do this.
Yeah, I think I agree with sir in the sense that we will have to decide right now what the data structure for these things will be. Like what you are saying, Rohan, is correct, but I think like this set of quote unquote standard functions you're referring to will just become so huge. And I think a lot of the implementation of the algorithms will come into the standard functions itself, right? Because, for example, if you think about the split and merging, I'll have to give you a standard function for doing a split. And then does that function also make sure that the weights are correct when you split? Which means that that function is also making sure that you're taking the max and the mins. Sorry, you're taking the, taking the correct positive and negative weights to each one of the nodes and so on. So a lot of the functionality will basically become a part of those functions. I don't think that is possible. What we'll instead have to give you is a data structure and tell you that, okay, look, this is how you access the data structure and do it there.
So to make it easy, let me ask one thing. So do you know, Diganta,
Yeah.
of any graph package? Okay.
Yeah. I was talking about NetworkX. So let me just bring up
So
its
that
documentation.
most of these packages, I presume, will give you the flexibility to decide the contents of each node, I presume, correct? You could make the nodes have several
Yeah.
elements, and you could decide that, no?
Yeah, so I think you can do that, but I think also mostly they give you names for nodes and then you can use some external data structure, index it with the names.
Oh, I see. Okay, so then what? Yeah, I guess then if we agree that we will use the same package of graph, a graph, thing, then it should be okay. No, and we decide how exactly a network is encoded into that graph data structure. That decision, if we make, then it is good enough. No, and anything that you don't have.
Okay, yeah, NetworkX does allow you to add attributes.
Yeah, that's what I said. If you can
Right.
add attributes, and whatever attributes that you want, then you'll be able to add to each of those nodes whatever attributes that you want. If that way, the graph data structure is extensible in terms of the attributes that you add. Then we are all set, huh?
Yeah. So we will treat the network as just a NetworkX graph,
Yeah.
which will have nodes. So each node will, keep track of what layer it is belonging to, whether it's an original node or a merged node, right?
Yeah, whatever information, that is something that we
Right.
have to decide. Yes.
Yeah, and similarly, each edge will also have to have a weight,
Correct.
right?
Yeah, but I don't know how you will, the bias will have to be fed as, how will it be treated? The bias, that decision.
That will have to be an attribute of the node itself, right?
Well, that will be like a constant node, one node, okay?
No. So it will be an attribute of the node itself, right? So the node will have a bunch of edges, input edges going in. It will have some bias inside the node, and then the output edges going out.
Yeah. So, but the bias node will not have anything coming in.
No. I'm saying the bias will be an attribute of the node itself. So in the sense, we'll have one node like this. We have multiple edges feeding in, and then this node will have as an attribute the bias.
Yeah. So see, there's no room for any, we'll have to be extremely clear about this here, okay? Because there's no room for ambiguity at all.
No, I think if we use NetworkX, one of the good things is that if we later on decide that we need more attributes,
yeah,
then that's a similar thing with using these external maps indexing as well.
No,
We don't.
I understand that at a certain level, Diganta, but when you do some, extracting the merge group, suppose that's what you're implementing, you will have to query some of these attributes. You will assume that some of those attributes are there, no?
Yes.
Yeah,
Yes.
so then there has to be an agreement between you and them as to how the attributes will be stored, in what order and those things, all that becomes important. Therefore, no, well, they seem conceptually trivial. When you're programming, even those small things will, create problems. No?
Yeah. As long as we are at every point, we maintain this sort of global synchronized list of attributes that each node contains.
That decision has to be made now, no? If possible, I would even, yeah.
Yeah, I mean, it would be good if it is made now, but even if not, as long as everybody is on the same page, then it's fine, right? In the sense that suppose we don't come to some decision now, later on while I am implementing, I decide that okay, look, I actually need this attribute in the node, right?
So that's fine with me. But I think what I propose is to have a common GitHub or something, okay? Where everybody has access to it, where you will put something even that can have both code as well as documents, okay? And
Right.
and that has to be kept as a synchronized thing. And so you can have two projects there, okay? I mean, there'll be one common thing which is shared, and you can have your own code, each of you, the two teams. But whatever is shared will have to be jointly owned, okay? And that's how I would do. So then I think I'm okay. So as long as then all that decision will not have to be made right today. But
yeah, I think that is the best way to go about it. Like keep a common GitHub and then make sure it's synchronized with that.
Okay. But who will create that?
I'll make that GitHub. So I'll make that GitHub and
yeah, but in that you should load this. I mean, of course, all the documents that we so far have, okay, and whatever the graph package that you're proposing should be there. Maybe that is so standard that everyone knows about it. Okay, so or at least a link to that if someone does not know about it. And from your side, given that now that is the one module that will be implemented and provided for you, all the rest of the tasks, I'm assuming that we'll have to, I'm assuming that you will do. Yeah, that is something that you will have to do. But that is true also. I completely agree with you. And let's see. So so we'll put our best thing forward. Yes.
So Diganta, so what we can agree right now that you will provide module as algorithm 3 as one module.
yeah.
We'll start working from step 1, the ink tech problem, the simulation and all.
Mhm.
And whoever has been assigned the step 2 in the group, he'll start working on that as well till it reaches the point to your module.
Yeah, so I mean, so hopefully I'll be able to get you this model fairly quickly. Yeah, so till it reaches this
Yeah,
point. Yes.
say you get it to us by Sunday. So let us say that we'll also work till that day to
Mhm.
get our code done by then also. So as soon as we get your module, we'll be able to use that, maybe figure out some problems that we are having after you provide the module, and
Yeah.
be done with the step 2 in the next few days.
Right.
We'll work on step 3, and maybe if we encounter some problems, then we can come back.
Yeah.
Yeah. So yeah, we can have that right now, that in the next few days we'll finish up till your module, and with your module step 2 will be complete, and we'll be there by. Just one second.
In addition to that, what I want from you guys is, I have a discussion among the team members, and I want like a declaration of who does what in your okay. And I want to review that, and then make sure that the workload is equitable, okay. And then I'll hold that person responsible, accountable for delivering that thing. And one advice from me is make it very clear, especially if the effort has to be done somewhat in parallel, okay? And that's when you'll be able to finish it. You will have to agree on completely the contract, okay? What the interfaces should be and so on. So that that person is able to do as much independently, okay, as possible. Whether there'll always be some dependency, and you will have to do that. But documenting first the interfaces and what its inputs and the outputs will be, kind of, you know. And I think as part of this, I guess what attributes to store as part of the graph, and what information you will store separately as something, a separate data structure that indexes into the nodes of the thing, will have to be decided pretty soon as well, isn't it?
Yeah. So
Who does that?
So what I'll do is I'll just make sure that you can, like, because oftentimes there are some restrictions on what kind of attributes you can add because of, things like it should be hashable and so on. So I'll make sure that there are no restrictions, and based on that, I'll give out at least. So if there are no restrictions, then we'll keep all the attributes within the graph itself. If there are any restrictions, let's just keep a single index and have everything indexed by that. Okay. In fact, I think the best and easiest way is to have everything indexed by the index itself and just decide on that right now. Right? Because then I think we'll have the most flexibility and the least chances of a clash going forward. If that is okay with everyone. Because I mean, any attribute that we can think of, we can have an external data structure and we can have an indexing, and the indexing will be based on this common integer ID, and that will be given by when you create the graph.
When you say an index, will it be something like that? It will be a sort of a dictionary with each neuron being the key, and
yes.
So it will be something like the incoming edges, outgoing edges, and bias.
Right. So basically each neuron, so you have a graph, and in that graph you have each neuron, and each neuron will be given a unique index, right?
Right.
And now this graph will also contain which all neurons are connected, right? So now what we'll have is we'll also have the fact that for each one of these connections, the neurons will have an attribute, or okay, so sorry. There will be one dict which will take, say, the neuron's index and give it a bias, right? So it will be something like index to bias. There will be another dict which gives edge to weight, right? There will be another for the simulation data, another for the lower bound, upper bound, and so on. This is basically the structure I'm proposing.
Are you proposing one dictionary for each neuron?
No. I'm proposing there will be one global dictionary for the entire network, which will take the index to the bias. One dictionary entry for each neuron, but one dictionary for the bias, one dictionary for this. So this is dict number 1. This is the bias dict. This is dict number 2, the weight dict.
So I got the first, third, and the fourth. But how are you thinking of storing the weights?
So the keys of the dictionary would be this pair of incoming and outgoing, the pair of the source and destination node.
So there the key changes. For the first, third, and fourth, the key is the same in the index, and it will
Right.
be a list of things inside it. Maybe
Right.
but for the weights, it will have a completely different key, and we'll have to figure. We'll have to call that key from the dictionary and get the value, right?
Yes, yes, yes. Because it is associated with the different objects, right? The first, third, and fourth are basically talking about node attributes, while the second is talking about edge attributes, right?
So what you could do is just provide a dictionary called weight inside the value itself, and then in the weight dictionary, if you call the neuron on which it is attached, you'll get that weight automatically.
So you're saying instead of this, you're saying something like,
Yeah. So IDX, you will have a weight dic.
so you're saying this.
IDX to it. Yeah, exactly.
Yeah, sure.
So that then everything can be found inside one index of the neuron, and then we get all the information there.
So just to be clear, you're saying that this will be source
Yes.
and this will be test.
IDX will be the source for the first dictionary, the text in.
Hmm.
Then there will be another dictionary, say WDIC, in which the source, the key will be IDX prime.
Hmm, hmm, hmm. Right?
And
Yeah.
this dictionary can be a part of a list in which the first element says the bias, second element is the dictionary, new dictionary, third element is the SIMVET, and the fourth.
The bias is already handled there, right? So why are you saying?
No,
Oh, okay. So you're saying that instead of having 4 different dicts, let's take basically IDX2 list of all of these things.
yes. That will be more efficient, right?
Sure.
That's-
Okay.
Yeah. So once we, I suggested this because once we then put in the sources IDX in the first dictionary, we get all the values right then and there. And once if we have decided on the indexes beforehand, then we'll be able to get everything together.
Hmm. So let me just check something. Whether what kind of attributes this network is supposed.
Yeah. So Ashutosh has also suggested that whoever does step 1, the output of his modules should also be in the same format. So this format you could just publish as some kind of a document on.
Yeah. I mean, I'm going to say that once this basic idea of at least the basic structure of this format, everybody should follow. Like there might be more entries in this dict. Like there might be more dicts, right?
These have to be specific. Yeah.
Yeah, but basically there will be a graph and there will be things. There will be dicts indexed by the indices of the nodes of that graph. Okay. So
Yeah.
this basic structure, if everybody follows the rest, I think we can sync up.
Yeah. Digant, just one sec. So you heard it. I'll just pass the mic.
Yeah.
Yeah, what I was saying was if, there are no more questions or comments to be made on the technical aspects of tasks or the project, I want to, take control of the display to
Yeah,
bring up
sure.
the logistics thing for which I need to share calendar. Okay.
Yeah.
So you can see the calendar, right? Diganta?
Yeah.
So we are here. See, I'll be leaving on the 23rd night.
Okay.
I'll be back on the 29th morning.
Okay.
So the first thing that I want to decide is, so next week, class schedule, okay? So I'll, we have one class on Tuesday, so we can do on Tuesday. I want to at least, there's some loose points about DPL. So that's all the technical stuff. Theoretical, what I call is the theory part, because there'll be, a final exam, and I decided to make it a take-home exam. Okay? So you could, work on it. So, really take-home exams are a little bit harder. I don't know. I mean, I could make. I mean, it's up to you. Okay, so I'll be back on the 29th. What we agreed upon was what? That you will have the thing is due on the 30th, something, the presentation, correct? One presentation. And I think I had 29th as the in-person class exam. What did I decide on the exam date? Okay. You guys are all leaving town on the 30th? When are you leaving town? So we'll have to have it.
I think, yeah, Hardik told me he's leaving on 30th. Other than that, I don't know.
See, what if I have a take-home exam, which I put out on the 30th or the 29th? I mean, 29th, give it on the 30th. The thing is that if you have to work on the exam, that will take away some time that you could have devoted on the project, correct? So all your exams get over by when? Huh? See, I'm okay if you're willing to. I can be. I mean, either I'll give it before and then the things. Then you will have to do. I mean, that'll take away some time. Anyway, you won't be working on the project. Probably only maybe 10% of the time. For your exams. So pretty much you have only 1 week to work. So pretty much you have to work on the. Anyway, that's. I mean, I won't say. I mean, you will have to manage that. That you can do. Why 15th December? I mean, why till 15th December? See, this is where I wanted to know. Hey, Diganta.
Yeah.
Not that this is not important, but nonetheless. Okay. When is SMT school?
I think it's 15 to 17. Let me just quickly check. But I think
When
it's
is the
15.
deadline for submitting something?
Let me check that. So there was a mail recently.
Yeah, from Madhukar.
Yeah, so I'll just bring that down. Yeah. By November 15th, so
It's
it's
already
over.
over.
It's already over.
No. The proposal has to be sent or the submission has to be sent?
It says that they had given a link for Google Doc, and it says that please submit your entries by November 15th.
No, entries for what?
For poster presentations.
Can you send, yeah, I mean, I'll also send. Madhukar, if it's too late, if it's just a proposal, they're not asking for any kind of a paper submission, right?
Yeah, it's just saying poster presentations and talks.
No. A proposal for the poster presentation, that's all they're asking, nah? Not the actual poster itself to be submitted.
I'm not sure because the word that they're using is entries. Okay. So I'm not sure whether they mean the actual poster or the proposal for the poster. So
Okay.
Yeah,
we will.
but we can, I mean, we can ask Madhukar and he can also say like, if it's too late, he'll just say it's too late. So,
Yeah, I think they should, that's okay. So let's do that. I mean, I don't think I want to put too much pressure on that. Okay, so we will deal with that. And I just want to make an entry there. Okay, whether we actually do it or not depends on the quality of what we have. Okay.
Right.
Now let me get back to what Rohan was proposing. Okay, so so what are you proposing, Rohan? So you will have the presentation on the 15th. I mean, I'm saying, what is the use? I mean, why postpone till 15th so that you will have these this week to work on it? But you'll all spread out, but you'll still communicate amongst yourself and you'll work. Then you have more time. Okay. Do you want to put it till 15th or a little bit earlier than that? Because you need that part done. So what are your constraints, Diganta?
So I mean, I'll be there on FST TCS. Before that, I have some amount of time. Thing is, I mean, I have work going on, but no deadline specifically. So I'll not be able to. I mean, not be able to give full time, but I'll be able to give as much time as I've been giving, if a little bit less, throughout up until December 15th. So December 15th works for me.
But the school itself starts on
15th itself. So I'll be traveling on 14th.
Then we'll have to leave a couple of days earlier. Okay. Yeah.
So maybe we can have it on December 12th.
Okay.
Is that okay with everyone?
Yeah. How about December 12th is what is this?
And I mean, just like if you guys have like do register for FSTCS and SATSMT school if you want to. At least SATSMT school is, if you're interested in formal verifications, you please should register students.
First of all, I'll have, we'll have to talk to Madhukar to see if we could submit something. Second of all, we'll have
Even if not, then just as attendees.
no,
right?
as an attendee, I will be attending, okay?
Yeah, even I'll be attending.
Yeah, but if we want to really get some poster or some talk or something presented, then we need at least a couple of days. I mean, the thing will have to be written here itself, okay? And during this week. And that responsibility we can take, okay? But what is important is that you guys should be available for some, one person will be made responsible on each team. And he needs to be willing to have a meeting. Yeah, online only. Yes. Yeah. That's right, but you guys will not be able to attend because you're all away, huh? None of you will be able to attend. It's a student. We can't be presenting it. I think there is also some other kind of a presentation, but I don't know what the requirements are. No. Let's not worry about that. Okay. So Jess, we'll decide on the thing, whether it's a secondary thing, whether we'll be able to put something there or not, because there's always other opportunities that are available, assuming that the final product is worth consideration for presentation anywhere. That depends on the quality of the thing, especially the quality of the experiments. Okay? And experiments, even if you have done a very good job, whether the experiments will be of interest to be presented will also be a thing. At least there has to be, we have to show some, okay, this method is improving over existing methods somehow. So there is some experiments also there. So tentatively, we will agree on 12th, okay? Tentatively, December 12th is the presentation. The exam then, in that case, you can even have it on the 30th, isn't it? Yeah. That's right. That I will do, not now, on because you're traveling on the bus. Submit on the 20th, on December 1st, no, 30th itself. 30th night, okay, before you leave. Yeah. Yeah, but certainly you don't want me to publish it on 30th and make it due on the 1st, correct? Because you'll be traveling on the 1st. Then you won't be able to do it. Yeah, so that we can decide on, so next week also. So regarding classes, so I'll be able to be here on Tuesday. So Tuesday, some part of it, I want to brush up on all the topics that I will be giving. Or 22nd, yes, 22nd, okay. Now, after that, so if we devote, that will not be project discussion. So he can do Wednesday and Thursday if you wish, okay. But then, okay, so then we actually cannot have classes on 23rd, 24th, correct? So if you want to have a project discussion next week with Diganta, then, I mean, I don't know, any project discussion then after that will have to be on WhatsApp or some other communication. Yeah. Yeah. The question is, before I leave, do you want to have a project discussion before that? I mean, we only have 1 day of class next week, which is 22nd, okay? Which I want to devote for clarifying on the topics and then the thing, and then just a couple of things like decision. There are a couple of topics that I left on the on DPLL. Then if you're okay with having project discussions, we are done with project discussion, then all that will be on kind of a WhatsApp or group thing that you arrange with Ganta on your own. Yeah. That I'm okay with that. Yes. Yeah. Okay. Fine. Yes. I may not even need the whole of 22nd. After that, you can continue with the thing. So there'll be one formal discussion, project discussion. After that, it will be informal with thing, and we will decide on exactly the date for the take home, when it will be out and when it will be in next Tuesday. Okay, after getting from both the constraints of the other folks, and Diganta will create the GitHub, okay, on the thing, and then we have decided December 12th to be the presentation online. Yeah.
Okay. So we're going to have one formal discussion on 22nd, right?
Yeah, the decision on 22nd will be about the date for the take-home exam. That's all.
Okay.
And before I leave, I will definitely grade the other assignments, so you'll have an idea.
Yeah. Over this weekend, I and Harsh will get that.
Yes, we'll have to do that.
Yeah.
Okay. So
Okay.
see you next week.
Yeah.
Yeah, you'll create the GitHub, and then we should.
Yeah, I'll create the GitHub and
Should there be another WhatsApp group or something to where people can ask questions about the project and so on?
yeah, sure. I'll there is a group, so I'll arrange it over there.
Yeah. I mean, if you want me in that group, you can add me. Yeah. So why don't you add me also into that group? Yeah. Okay. Thank you. Yeah. So any other questions? So we're done now. Okay. Good. Let's see you next week. Thank you, Diganta.
Yeah, sure. So Hardik, just before ending, so this one-on-one meeting with Hardik that was supposed to happen, it hasn't happened yet. We had planned to meet tonight. He said that he's busy at 5.
Ah, okay. He did respond to you. I hadn't seen message. Yeah, tonight should be okay, but I'll be taking a shuttle at 6 o'clock. So if it is after 8:30, then I'm okay with it.
He was saying at 10 o'clock. Which is fine with me, but
I know you guys are night birds, but I have more normal time.
right.
I'm actually like that.
I'll ask him if 9 is okay.
No, 9:30. If we can do 9:30, that would be better for me. Yeah.
Sure. I'll ask him 9:30. Yeah.
Okay. Or even 10 is okay. What I will do is I want to get the status to see if there are any issues, etc. And then we'll have to decide on this schedule for him as well. Okay, those
Right.
parts are important. And after that, if you want to continue the technical discussion with him one-on-one, I'm okay. So even 10 p.m. is okay with me. Yeah.
Sure. Okay. If that is okay with you, then but I can, yeah, okay, sure. I'll tell him.
Yeah. Okay.
So 10 p.m. tonight, right?
10 p.m. Yes. Okay, Diganta.
Okay. Okay, sir. Bye.